Now that we've learned 3 ways to solve a system, we're going to look at application problems involving systems. So before we get into some practice, let's review the 3 methods that we've learned. So the first one that we did was graphing. Now remember for graphing that both equations need to be in y equals mx plus b, slope-intercept form. Then you graph the lines and the solution is where the lines cross. So we did that method first. The second method we did was substitution. The answer should still be the same, it's just a different method of finding the answer where the lines cross. So when you do substitution, you must have one variable, usually either x or y are the ones I'm looking at. One variable needs to be alone on one side of the equal sign, just somewhere within the system. It can be mx plus b, but it could also be something like x equals 2y plus 5. Like, that's okay, x is by itself. Then we learned elimination. That's our most recent one that we've done. And when you use this method, both equations should be in standard form, so everything's all lined up. Then you have to have the same coefficients with opposite signs in front of the variable you're trying to eliminate. So like 5x and negative 5x. Same number, different signs. So brief overview, we spent a lot of time doing those 3 methods. Now we're going to look at how to apply systems to real life and then use one of the methods to solve that system. So this is kind of some good review information to have nearby when you're solving. Now today, like I said, we're focusing on application problems. So I'm going to give you 3 steps for solving a word problem that involves systems. First things first, you read it, okay? That's like before step 1. Obviously read it, underline important information, and then you need to define 2 variables. So there's always 2 things that you're solving for in these systems application problems. You then need to write 2 equations. We're talking about systems, which means 2 or more equations. We always do 2 in this class. So word problems on this exam, this quiz coming up, write 2 equations. Then you're going to choose one of your 3 methods, and I will tell you right now, if given the choice, you should never choose graphing, especially in a word problem, because we get decimals a lot, because we talk about money a lot in word problems. So if something's $2.50, I can't see that on a graph. My eyes aren't that good. So never choose graphing. Choose either substitution or elimination to solve for both variables. So you should get 2 answers on all of these application problems. So we're going to do, let's see, there's 4 here. We're going to do 4 examples. These just take practice. Let's read it. Number 1. Caitlin had a clothing sale where she sold dresses and pants. Good for Caitlin. That sentence is kind of useless. It kind of tells me I'm talking about dresses and pants, but that's it. All right, here's where I get into the good stuff. Dresses cost $8. Pants cost $5.50. Caitlin sold 37 items and she made $241 in sales. Pretty decent. Go, Caitlin. I want to try to figure out how many of each type of clothing did she sell. Step 1 is to find what I'm trying to solve for. And the question usually gives that away. So how many of each type of clothing? Well, there's 2 types of clothing. They're dresses and pants. Those are my variables. So I'll do D for dresses and P for pants. Try to figure out how many of each item she sold. So writing the 2 equations. We saw one of these on the notes last time. Obviously, you got to figure out, okay, well, what information goes in one equation, what information goes in the other equation. If you have a problem like this, where some of the numbers are money numbers, those need to all go together in one money equation. So I kind of just do this. So one equation is talking about the dollar amounts, the money. Well, let's see, dresses cost $8, pants cost $5.50, and Caitlin made $241. So I would arrange that information. $8 for dresses, so 8 Ds. On top of that, she's going to make $5.50 for every pair of pants sold, so 550p. That should equal how much she made, 241. Okay, so I've used all the dollar amounts. The only number left is 37. I should say too, in both equations, you should use both variables. So in equation number 2, all I know is she sold a total of 37 items between dresses and pants. So this equation deals with the number of items. Again, this is really similar to the popcorn question on the last notes. But I know that between dresses and pants, so D plus P, there were 37 items sold. Okay, so I've got my system. Step 2 is done. Hopefully you feel pretty confident with substitution and elimination now, and you just pick whichever method maybe you like best, maybe whichever one it's set up best for, and you solve the system from there. So what I'm gonna do is kind of bring it over here and recopy the system. I wouldn't normally do this, but the way that the answer kind of wanted me to fill things in here, I don't have a ton of space right here. So I just need to solve the system. Honestly, you guys, for me, I like substitution better. So if I get the choice, I'm going to do substitution every time if it kind of lends itself nicely to that. I would say on this problem, either method would be about the same amount of work. So because I know I'm going to use substitution in other examples, I'll do elimination on this one. But you just have to think, if you want to do substitution, you have to have a variable by itself. So you probably want to go down here to the second equation and maybe subtract P to the other side, so then D is alone. I'm going to go for elimination. I will tell you it makes no difference. You should get the same answer regardless of the method that you choose. So if I'm going to do elimination, everything needs to be all lined up in standard form, which it is, D's and then P's. I need to get the same coefficients in front of D or P, one positive, one negative. So here's what I'm going to do. Second equation. I'm not going to mess with the 550. I don't want to focus on decimals if I don't have to. So I'm going to go for getting the D's the same. I need this to be -8. So that's what I'm going to multiply by. And that's just a 1 right there. Make sure you distribute it to all of the numbers. So let's rewrite it here. This equation would turn into -8D minus 8P equals, be careful here, the bigger the numbers get, the easier it is to make a mistake. -296. Okay, so get rid of that one for now. And what I'm going to do, I got a lot of colors going on, but I'm going to add the equations now. And again, I'm kind of ignoring this middle row. Hopefully that doesn't throw you off. But 8D plus -8D, those eliminate, and that's 0. Don't even write it. Decimals leave a lot of room for error, so be careful. 550 plus -8 is -2.5p. And then you got 241 plus -296. So that's -55. Pretty easy to solve from P from here. So I'm going to divide by -2.5. And it looks like Caitlin sold 22 pairs of pants. The good thing about word problems, guys, the answer should make sense. So if you get that Caitlin sold 22.3 pairs of pants, that makes no sense. If Caitlin sells -20 pairs of pants, that doesn't make sense either. Should be like positive whole numbers here that we're getting for our answers. Now I need to figure out how many dresses that she sold. So I'm going to come back, and I'm actually going to come back to the original system here, what I wrote over here. You could plug it into this new green one. Plugging it in anywhere will get you the other answer. But I'm going to choose to plug it into this plain equation right here, D plus P equals 37. The less numbers, the easier it is going to be to plug it in. So let's see, D plus P, we'll do a different color. I know that Caitlin sold 22 pairs of pants. So if I plug that in and then I just subtract 22 over, looks like Caitlin sold 15 dresses. So I've got both my answers. All right, let's do another one. So I don't have all the weird answer blanks here, so I just got to remember the steps from the front, flip back and forth if you need to. So example 2 says Jacinda's age is 2 less, so Jacinda's age is 2 less than triple Morgan's age. The sum, it's a big word, of their ages is 26. How old are Jacinda and Morgan? A lot of times when you're talking about two different people like this, you're trying to find something about them, and I want to know their ages. How old are they? So let's just use J and M. All right, so I've got my two variables. Now I need to write two equations. A lot of times the sentences, so there's no money involved in this one. The way I organize the information is going to be different than this past example. A lot of times you'll see that the sentences separate the information, and that's exactly what's happening here. So this first sentence, I can write an equation from that. Jacinda's age is, so let's just do this. Jacinda, and if you guys remember, is means equals. So Jacinda equals 2 less than triple Morgan. You have to be careful. Less than, yeah, that means subtract, but you also have to write it backwards. This is kind of coming back from the beginning of the semester here. So 2 less than triple Morgan's age would actually look like this. Triple Morgan's age times by 3 and then subtract 2. Be careful if you see less than. The second sentence, I can write the second equation from that. I know that sum means add. So if I add Jacinda and Morgan's ages, I'm going to get 26. There's is again, equals 26. Okay. If I look at this, and now that it's set up, I just pick either substitution or elimination to solve. Here's where you're going to have a lot of benefits if you're comfortable with both methods. This is set up way nicer for substitution because I have a J by itself. So that's exactly what I'm going to do. J is the same thing as 3m minus 2 because those are equal. So I can come down here to the second equation, and instead of writing J, I can replace it with 3m minus 2. So I'd rewrite the second equation like this. Now I have an equation that just has m's, so I can combine the m's. And I can hopefully pretty easily solve from here. So then if I divide by 4, I'm running out of room, but Morgan would be 7 years old. I don't know why, but I kind of figured she'd be older than that. Once I have Morgan's age, I can bring my M back up to the top and I can plug it in to find Jacinda's age. And if you remember for substitution, if you plug it into the equation where there was a variable alone, it's the least amount of work. So if I plug it in here, I know that Morgan is 7, so I'm going to put that in for M. And then I just have to do 21 minus 2, so Jacinda is 19 years old. Okay, got my answer. You could have done elimination on that one, but if you use the method that it's set up better for, you're just going to spend a lot less time doing the problem. All right, example 3, and notice this note I made right here. To pay close attention to this problem, this problem is really popular. It shows up a lot. It definitely will be on the final, definitely will be on the test, may even see it next semester. It's called the coin problem. So here she goes. Craig has 18 coins in his pocket, all of which are nickels and quarters. The total amount of money in his pocket is $3.30. Find the number of nickels and quarters in Craig's pocket. All right, define the variables. I want to find how many nickels does Craig have, how many quarters. Please tell me that no one walks around with 18 coins in their pocket. That sounds noisy. But Craig does, so we're going to roll with it. I need to write two equations. So this setup, and you'll see it every time, it's done the same way on the coin problem. It's kind of similar to this first example, where one equation deals with the money and one equation deals with like how many items you have. So let's do that same setup here. And I'm going to put number of coins because items, I'm talking about coins on this one. Here's why this one's kind of tricky. There's only two numbers, but there are actually numbers that you use in this problem that are not in the sentences. And that shows up in the money problem. So I know that Craig has $3.30 in his pocket. That's kind of the total that's going to go by itself. And I need to put nickels and quarters over here. You have to factor in yourself how much a nickel is worth, how much a quarter is worth. You can't just do n plus q equals 330. Doesn't work like that. If I have 2 quarters, I don't have $2. Okay, I know that a nickel is worth 5 cents. So you have to write it like this, 0.05 n. Don't write 0.5, that's 50 cents. A nickel is only 5 cents. So you have to write 0.05 n. So that's how much I would have based off of how many nickels I have in my pocket. And then Craig, you would do 0.25 times Q to get the money off of how many quarters he has in his pocket. Add those together, that should equal 330. Okay, so that can be tricky. The money problem or equation on the coin problem, you have to factor in yourself how much the coins are worth. Okay, so I use that dollar amount there. The second equation just deals with how many coins are in his pocket. Well, I know that there's 18 coins. They told me that. So this equation's real plain. Between the nickels and the quarters, there's 18 coins. All right, the reason that this problem can be tricky is that first part, coming up with the numbers yourself. The second part, there's like nasty decimals being used here. And I don't know about you, but like I'm probably gonna mess up if it's 0.05 or 0.25. So I'm gonna give you a helpful hint here. You can actually clear the decimal on this problem. And here's how you do that. If you just move the decimal twice on each number, or essentially you guys, you're multiplying every number by 100. That's what's happening when you move the decimal twice. You can clear out the decimal. So if I moved it twice, it would look like this. 5n plus 25q equals 330. I'll make a note. Move decimal twice. So personally, I think that this system is a little bit easier to work with. I don't have any decimals. Yeah, there's a really big number, but I'm probably less likely to make a mistake in my calculator. Okay, so that's the system I'm going to use. Let me just copy down that. So here's my system that I'm going with, the ones in purple here. So again, you can go for substitution or elimination. I personally like substitution, so that's the method I'm going to do right now. And I think you guys could probably benefit from seeing more substitution examples and practicing that than elimination. So I know I need a variable alone. So I'm going to come to the second equation because I see plain n's and plain q's. And here's what I'm going to do. I'm going to subtract q over, and I'm going to have n equals 18 minus q. Okay, let's scribble this out. These problems become a lot of work. That's kind of another downfall. So now here's my system. Now I have a variable by itself. So n is the same thing as 18 minus q. So I'm going to come up to this other equation, and I'm going to plug in 18 minus q where n sits. Okay, so I'm going to rewrite this problem right here. We'll do the work over to the left. Instead of n next to the 5, I'm going to put 18 minus q in parentheses. And then I just distribute, and I can solve this for q. I promise we'll do a lot of examples of the coin problem because it is kind of tricky. But you guys can all get it. Then I combine the q's, and that would be 20 I trust that you guys can solve a two-step equation from there, so let's just plug it into the calculator to save some time. Craig has 12 quarters in his pocket. Well, that's better. I'd rather have more quarters than nickels, I guess, if I'm carrying around this many coins. So now you got to figure out how many nickels he has. Well, if you come back with substitution to where there was a variable alone, which is right here, this is the easiest place to figure out how many nickels he has. Because I know quarters is 12, so I'm just going to do 18 minus 12. He would have 6 nickels. Again, if you go through all this work and you get a nice positive whole number, you probably did it right. Don't settle for negative quarters or like 2.5 quarters in Craig's pocket. That doesn't make sense. Okay, one more example. Dan and Steve bought some pens and pencils. Good for them. Dan bought 4 pens, 5 pencils, and he spent $6.71. Steve bought 5 pens, 3 pencils. He spent $7.12. Find the price of a pen and the price of a pencil. All right, let's define my variables. I'm going to do P for pen, and maybe just like C for pencils. Okay, that's what I'm trying to get at. Find the price of both of those. So this setup, and this one may be a little bit easier than some of the others. This is not organize the money information together and then the other numbers in the other equation. This one, the two people kind of separate the equations. So one equation is about Dan and one is about Steve. So organize Dan's sentence into an equation. He bought 4 pens, add on to that 5 pencils, and he spent $6.71. Steve bought 5 pens and 3 pencils, and he spent $7.12. Now I'd have to solve this, and that's what I want you guys to do. So you solve it. I would definitely use elimination on this because it's all lined up. You just need to get the same number in front of P or C, one positive, one negative. Okay, so figure out the price of both, and I'll check that next time.